Hello everyone, myself Sanskriti Jain from Case 23 and welcome to today's session. I'm really glad you are here because the topic we are diving into is not just scientifically fascinating but deeply connected to human identity, history and the pursuit of justice. Today we are exploring forensic anthropology, a field that uses the human skeleton as a record keeper, a storyteller to understand who a person was, how they lived and in some cases how they died. In the next few minutes, you will learn what forensic anthropology is, how experts work with these bones, how they estimate age, sex, height, ancestry, trauma, and much more. So, get comfortable, grab your notes, and let's begin our journey into the world where bones speak and science listens. So, what is forensic anthropology? Forensic anthropology is a specialized branch of physical anthropology, the science that studies human biological variation. But forensic anthropology has a more specific purpose. It applies that understanding to legal and investigative context. In simple words, forensic anthropology helps answer questions like whose bones are these, how old was the person male or female, how tall was the person, what population did they belong to, are there any signs of injury, and when did those injuries occur. Whenever bodies are decomposed, skeletonized, burned, buried, or fragmented, soft tissues vanish, but the skeleton remains, and the skeleton contains a remarkable amount of information. The forensic anthropologists work with this information to reconstruct what we call the biological profile, the set of characteristics that describe an individual. This field plays a crucial role in criminal investigation, natural disaster, plane crashes, wars, human rights investigations, and even archaeological discoveries. It allows us to connect science with truth, often giving identity back to those who can no longer speak for themselves. So, now let's talk about a brief history of forensic anthropology. The roots of forensic anthropology can be traced back to the earliest anatomical studies. For centuries, physicians and anatomists studied human bones to understand the structure and the variation. But the application of this knowledge to legal cases didn't become formalized until the 19th century. One of the earliest figures is Thomas Dwight, often called the father of forensic anthropology. He led the foundation for studying skeletal remains scientifically in legal context. Later, in the mid-20th century, researchers like T. Dale Stewart, Wilton Grogman and Clyde Snow refined methods, standardized techniques, and demonstrated how skeletal analysis could help solve cases. By the late 20th century, the discipline expanded dramatically, with anthropologists contributing to the identification of war victims, genocide investigation, mass disaster, and human rights cases. Today, forensic anthropology is recognized globally and works hand in hand with forensic pathology, archaeology, and other investigative sciences. So, what is the role of forensic anthropologists? Their work begins the moment skeletal remains are discovered. First, they assist in the recovery of those remains. This is not picking up bones, it is careful, archaeologically style excavation where every piece is mapped, documented, and collected with precision. Once in the lab, anthropologists clean and reconstruct the bone. Sometimes the skeleton is complete, other times it may be burned, crashed, scattered by animals, or fragmented by trauma. From this, they begin building the biological profile, determining the age, sex, stature, ancestry, and identifying unique features. They examine trauma. Were there any broken bones? Were those injuries inflicted before death, at the time of death, or after death? Did the individual experience blunt force trauma, sharp force trauma, gunshot wounds, fire damage, etc.? They also evaluate post-mortem changes, things that happen to bones after death due to environment, soil, animal, temperature, etc. Finally, they prepare reports and often testify in court, explaining their findings in clear, understandable language. The work of a forensic anthropologist blends science, investigation, and empathy because behind every bone is a real human being with a story. So, how can we identify human versus animal bones? One of the first questions in any case involving bones is surprisingly simple. Are these human remains? At first glance, some animal bones resemble human bones and vice versa. So, anthropologists use multiple clues. Human bones tend to be less dense with more refined muscle attachment marking. Animal bones are often thicker, heavier, and more robust, especially in four-legged animals that bear weight differently. The pelvis, skull, and long bones have distinctive characteristics in humans. For example, the human skull is rounded with large brain case, while many animals have elongated snouts or differently shaped cranial vaults. Microscopic examination also helps. Human bones show secondary osteons, while many animals have a structure called plexiform bone forming a brick-like pattern. Distinguishing human from non-human remains is a crucial first step because if the bones aren't human, the investigation takes an entirely different direction. Now, how can we estimate the age from the skeleton? Estimating age is one of the most fascinating aspects of forensic anthropology because the skeleton changes continuously throughout the life. In children and adolescents, age estimation is highly accurate. This is because the bones develop in predictable stages. The appearance and fusion of growth plate, the long bones, and especially the development and eruption of the teeth. For example, specific teeth erupt at very predictable ages. Growth plates, called epiphyses, also fuse at known age range. The medial end of the clavicle, for instance, is one of the last areas to fuse, usually around the early 20s. In adult, age estimation becomes more complex. Anthropologists rely on degenerative changes, including the surface of the pubic symphysis, the auricular surface of the pelvis, the cranial suture closure, and the changes to the ends of ribs. The teeth also provide clues. A classic method, a Gustafsson method, uses features like tooth wear, secondary dentin, and root transparency to estimate age. Although adult age estimation isn't exact, it provides a scientifically reasonable range. How can we determine the biological sex using skeleton? Sex determination from the skeleton is crucial because it narrows down identification significantly. The pelvis is the most reliable indicator because human females have adaptations for childbirth. A wider pelvic inlet, a broader subpubic angle, and a sebaceous birth canal are unmistakable biological traits. Male pelvis are narrower, deeper, and more robust. The skull also provides important clues. Male skulls are often pronounced brow ridges, square chins, larger mastoid process, and rugged muscle marking. Female skulls tend to be smoother with round contours. Even long bones can help as male tend to have thicker, stronger bones due to greater muscle mass. When available, DNA from bones provide a definitive answer, but skeletal analysis alone is not enough for reliable sex estimation. Stature estimation from skeleton. Estimating height is done by measuring long bones. The femur provides the most accurate estimate, followed by tibia and the humerus. Anthropologists use mathematical formulas called regression equations which are tailored to different populations. By substituting the bone length into these equations, they can estimate an individual's height, usually within a few centimeters. Ancestry and population affinity. Ancestry estimation involves understanding patterns of human variation that have developed due to genetics, historical, and environmental factors. Anthropologists look at the nasal aperture shape, orbital shape, zygomatic arcs, dental traits, cranial measurements, etc. It is important to clarify that modern forensic anthropology focuses on population affinity, not outdated racial categories. Human variation is continuous, complex, and shaped by thousands of years of migration and mixture. This analysis helps narrow down possible origins of unidentified remains. Now, how can we do trauma analysis using skeleton? Bones keep a record of trauma, and forensic anthropologists can interpret these skeletal signatures. Antemortem injuries show healing, meaning the individual survived the injury at least for a short time. These might include healed fractures, remodeled bone, and surgical implants. Perimortem injuries occur around the time of death. These are especially important because they may indicate cause or manner of death. Fresh bones bend and break differently from dry bones, so anthropologists can identify perimortem fractures even after years. Postmortem damage, on the other hand, happens after death, often due to animal activity, environmental effects, or excavation tools. Anthropologists can differentiate between blunt force trauma, sharp force trauma, gunshot wounds, and fire-related changes, providing crucial insights through the investigation. Postmortem changes of the skeleton. After death, bones undergo changes depending on the environment. Sun exposure may bleach bones, soil acidity can stain or erode them, water transport might scatter or polish bones, animals may gnaw marks and scatter skeletal elements. Studying these factors help estimate the time since death and reconstruct the events after the death. Individual identification. Finally, the forensic anthropologists look for unique identifiers. These include past injuries, congenital anomalies, bone diseases, dental restorations, surgical implants, and even specific bone shapes. When matched with medical records or dental charts, these characteristics can provide a positive identification. Forensic anthropology combines science, humanity, and detective work. It gives identity back to the unknown, answers to the families, and truth to the investigations. From determining age and sex to interpreting trauma and environmental effects, the skeleton becomes a powerful witness. I hope this session has given you a clear and comprehensive introduction to the world of forensic anthropology. But this is just the beginning. There is much more to explore, from advanced trauma analysis to skeletal anomalies to a forensic archaeology, facial reconstruction, and real case application. So, with that, we'll continue this session in the next part, where we dive even deeper into the techniques, tools, and fascinating discovery with the experience field. Thank you for watching. Thank you for learning. I'll see you soon in part 2.